Hi, I'm an old guy and I do maths. And what I thought I might do today is to take a previous question involving a network where we had to find some missing values and show you how when the transition matrix is created, how it actually operates on a population. I'll explain that terminology in a minute. So here we have our network, and the transition matrix is made up from this network. Now, excuse my illegible scrawl here. That's meant to be an M. So what have we got? Well, let's start by setting up the matrix AMN. AMN. This is the starting point. This is the finishing point. So things move from M to A to M, A to N. Things stay put. That's what these little circles with the arrows on them indicate. So 40% of things that are in A remain in A over a period of time. So making up the matrix very quickly, A to A, 0.4, A to M, where is it there, 0.1, A to N, 0.5, and so forth and so on. If you need to see how this is constructed, there's a previous video on this using these exact numbers. Now, what I'm going to do today is I'm going to take the population A, M, and N. So this is A, this is M, and this is N. And I'm going to multiply it by the transition matrix. And when I do that, I'm going to get the changes that are brought about by this transition matrix. So I've done the first one. So everybody starts off with 100 members in their sets, whatever they are, people, things, cars, whatever. And we multiply this by this transition matrix. So 0.4 times 100 is 40, plus 0.2 times 100 is 20, plus 0.3 times 100 is 30. Okay, hopefully that all makes sense. Right. Next line. 0.1 times 100 is 10. 0.3 times 100. Did I point to this one first of all? It should be 0.1 times 100. 0.3 times 100 is 30. 0.6 times 100 is 60. That gives us 100. 60 plus 30 plus 10. 0.5 times 100 is 50. 0.5 times 100 is 50. 0.1 times 100 is 10. Now, when I add these numbers up, what I get is this matrix, which is the change in numbers from this state to some time later when this matrix has operated upon it. How does a transition matrix work? Well, what it's designed to do is it's designed to reflect changes in, I call it a population. It's a group of things. This could be pupils in classes. It could be nesting birds. It could be anything. And over a period, whether that is a day, a week, a month, a year, a term, anything, what we do is we use the transition matrix to calculate the changes. So how many we'll call it people. How many people stay in A? How many people go from A to M? How many people go from M to N? That sort of thing. Now, the result of that is this matrix here. After the first period, what we find is we still have the same number of people or things, but we find that the numbers have changed. Well, some of the numbers have changed. We have fewer people in group A, we have more people in group N, but we have the same number of people in group M. And that, very briefly, is how a transition matrix operates upon a population. Thanks very much for watching. I hope you found that useful. If you did, please like and subscribe, and I'll see you next time. Bye.